exploring the idea of surds and how we can add them together. So to start off with, we need to think about or change the way we think about surds. So more often than not, a surds question is going to ask you to simplify the following. And we've known how to do this with other types of numbers. So if I just wrote down a fraction of, let's say, a half take away 3/7, at the moment we can't do this operation. We know we can simplify it, but we can't do it in this current form. So what we have to do is we have to jiggle with it a little bit. We have to try and make a common denominator. And when we do that, when we make a common denominator of 14, we can then simplify this fraction. So 7 take away 6 is 1, 14. So this simplifies to 1 over 14. Now we need to remember that surds, again, are just numbers. They are bound by this sign, which is called a radical, that sign here. And sometimes we are asked to simplify them. So I'm going to give you an example of root 2 plus 3 root 2. And it's useful to know that, again, root 2 is just a value. So the way I'd read this is 1 lot of root 2 plus 3 lots of root 2. So therefore, in total, if I have a 1 lot of something and 3 lots of something, I must have 4 lots of something. And again, if I had, let's say, 5 lots of root 2 and I subtract 3 lots of root 2, that's going to leave me with 2 lots of root 2. So, what I'd like you to have a go at the question 1, pause the video. Perfect. I'm just going to go through your answers. So it should be 2 root 3, it should be 9 root 7, it should be 6 root 5, 1, 2, 3, 4, 5, 6 root 2. This should be 9 root 3, 12 root 2, take away 2 root 2 is 10 root 2. And then lastly, it's going to be 5 root 2 plus 9, so it's 5 root 6. Okay, well done if you got those correct. What we're going to move on to then is how we can simplify surds which don't have the same sort of value under the radical. Every single question we looked at here had the same value under the radical, so we could collect the same amount of lots. Now we're going to have to think about our fractions example, where we have to sort of mess with our surd to make it a similar thing. So this question here I'm going to go through is root 27 plus 5 root 3. Now, in the previous lesson, we looked at how we could mess with root 27, and we could rewrite it as the multiple of 2 factors. The factors I'm going to choose are going to be root 9 and root 3, and the reason I chose 9 and 3 is not only because 9 is a square number, but if I'm trying to add it onto something which has, let's say, a base of root 3, I want my value to have some form of root 3. So this is going to be root 9 root 3 plus 5 root 3. Root 9 we know is 3, so it's 3 root 3 plus 5 root 3, which would give us 8 root 3. So, I'd like us to have a go at question 2, please. So pause the video and have a go. Just going to go through the answers. So this is going to be 2 root 2, so it's 3 root 2. This is going to be 3 root 3, so this is root 3. This is going to be 2 root 3, so this is root 3. Root 7, this is going to be 2 root 7, so it's 3 root 7. 10 root 6, take away 2 root 6, is going to be 8 root 6. Root 20 and root 45, well this is 9 root 5, this is 4 root 5, so 2 and 3 is 5 root 5. This is 5, 25 and 5, so it's 5 root 5, 5 root 5, so it's 10 root 5. Root 32 plus 5 root 2, so this is 16, so it's 9 root 2. 48 is 16 times 3, so it's 4, 5, 11 root 3. 20 root 5 subtract 80 root 5, well 80 root 5 is going to be 16 times 5, which is 4, so 16 root 5 altogether. 9 root 7 and 63, well 63 is 3 root 7, so this is 12 root 7. And the bottom one, root 40, is 4 root 10, 10 take away 4 is 6 root 10. Okay, sorry about that, took a little bit of time. But it's really important that we can do these surds, and as you see I did it in my head. That's because when I'm looking at surds, I'm really thinking about my square numbers. This becomes really important when I start to think about simplifying surds where I have different bases and I've got coefficients of my square root sign of my radical. I need to be really careful. So I'm going to have a look at 4 root 20, subtract 7 root 5, and I'm going to try and work out what this would be. So the first thing I'm going to do is I'm going to work out my surds. This is root 20, so I'm going to rewrite this as 4 and then root 4 root 5, subtract 7 root 5. Now I know that root 4 is 2 and 4 times 2 is 8, so this is 8 root 5. So just check, you can multiply these two values together, they are just numbers. We get 8 root 5, subtract 7 root 5 would leave me with the answer of just root 5. So that should be enough information for you to pause the video and have a go at these questions here. And then whilst you're doing that, I'm just going to start populating in the answers. So, 17 root 2, 11 root 3, 5, 7 root 3. So I'm just going to go through the answers: 7 root 3, 2 root 5, and 19 root 2, and lastly 9 root 7. So I'd like you to check all of them, make sure you've got them right, and what we're going to move on to just finally is we're just going to talk about some scenarios which can't always happen. So if I had a question, let's say, and it was 5 lots of root 2 plus 3 take away 2 lots of root 2 plus 5, looking at this question, it's obvious that I've got some things which can simplify because I've got the 5 root 2 and the negative 2 root 2. I looked at how I could do that in the first part of this video. 5 root 2 take away 2 root 2 is going to be 3 root 2. Positive 3 and positive 5 is going to make positive 8, but quite often you'd be thinking, what can I do from this stage? And you might try and combine it. However, this root 2 is an actual value. So unless we're going to use our calculator and do 3 multiplied by root 2 plus 8, this is in its simplest form. We can't go any further than this. So, thank you for watching and thank you for having a go at adding surds. If you have any questions or you're unsure where to go next, please feel free to email me and hopefully I'll see you in the next video.